we're going to solve some systems of equations with 3 variables today. And we're going to do it using some elimination. You can do substitution on these. I think they kind of play well for elimination as well. So here's kind of the goal. We're going to pair up 2 equations and a different 2 equations, and we're going to eliminate the same variable. So if you look, here's our first problem. I copied the first 2. I put them right here. I copied the second and the third one. I put them right here. Now we're going to pair these up and we're going to eliminate the same variable from both of them. It doesn't matter which variable you get rid of first. It works for all of them. But I always say, like, if you look at the equations as a whole, is there anything that jumps out as like easiest to match up? And this one, not necessarily, but let's say for comfort of what we usually do, let's get rid of the z's first. And then you'll see we'll have like an xy system left. So if we look at the first one, I have z and I have 2z. If I want those to cancel out, I'm going to multiply this top equation by -2, because then we'll have -2z and positive 2z. So -2 times -4x is positive 8x minus 14y minus 2z equals -46. So now I'm looking at those bottom 2 lines. 6x plus 8x is 14x. -4y, -14y is -18y. The z's are gone. Over here, -24 and -46 would be -70. We're going to get rid of the same variable with the other pairing. So we're going to get rid of the z's again. Now we have 2 and 5. We can make them both 10. And you want one positive, one negative, which they already have one positive, one negative. So I'm going to hit the top with 5, the second one with a 2, and then they'll cancel each other out. Top line times 5 would give us 30x minus 20y plus 10z equals -120. The second equation by 2 would give us -16x plus 12y minus 10z equals 50. So if we combine our stuff here, 30x minus 16x is 14x. -20y plus 12y is -8y. Z's are gone, and this comes out to -70. Once you have it down to the same 2 variables, you're going to bring them together. I'll just go ahead and rewrite this right underneath here. 14x minus 8y equals -70. And we're going to solve this like we've been doing with the 2 variable systems. Get the x's or the y's to match up and cancel out. If you look, the x's are already the same. We do want one to be positive, one to be negative, so we can multiply an equation by -1. Take one whole equation, make everything the opposite. Boop, beep, boop. Now we're good to go. The x's gone. The y's, I have positive 18y minus 8y, that's 10y. And here, positive 70 minus 70 is 0. Okay, 10y equals 0, divide by 10, y equals 0. As soon as you have a variable, it gets a lot easier. You can just take it back a step. I'm going to take it right over here since I have the space. And I'm going to substitute in 0 for y, and then I'll be able to figure out x. So 14x minus 8 times 0 equals -70. 8 times 0 is just 0, so we have 14x equals -70. And if we divide that by 14, we get x equals -5. So we have x, we have y. We just need z, which we eliminated first. So we have to go back to one of the original equations, doesn't matter which one, and we'll solve for z. So let's say I went with the first equation. That looks easiest to me. -4x, x is -5, plus 7y, y is 0, plus z equals 23. So let's see what we got. Look, 7 times 0 is 0. It's gone. -4 times -5 is 20. So 20 plus z equals 23. We can just subtract 20 from both sides. Z equals 3. Now we're going to write this like a 3-piece coordinate here, just x, y, z. So we're going to say -5, 0, 3. Pretty tough. But it's crazy because once you do these systems with 3 variables, when you go back to the ones with 2, they feel so easy. Let's try one more. here we go. Here's the original system. Again, I paired up the first two right here. I paired up the last two over here. We're going to get rid of the same variable. Now, if you notice, look at those x's. You have 9, 18, and 6. They can all go into 18, which means we wouldn't have to multiply that middle one at all. So let's try that one. Let's get rid of the x's. So the first pairing, I'm going to multiply that top one by 2. That would give us negative 18x plus 16y plus 10z equals 56. Now our x's will go away. Negative 5y plus 16y is 11y. 9z plus 10z is 19z. And negative 43 plus 56, same as 56 minus 43, that's 13. So we're going to also get rid of the x's on the other one. I have 18x and negative 6x, so I'm going to multiply the negative 6 by 3. We're going to get the whole equation by 3. Negative 18x plus 12y minus 6z equals 24. If it helps, you could rewrite that top one right underneath. 18x minus 5y plus 9z equals negative 43. So again, x's will cancel out. The y's, 12y minus 5y is 7y. Negative 6z plus 9z is 3z. 24 minus 43 is negative 19. So we're going to bring them together. I'll just write this one right over here. 7y plus 3z equals negative 19. I'm going to grab a calculator. We got to get either the y's to match up or the z's to match up. I'm going to do the y's on this one. 11 and 7. We can make them both 77. And you could always do that. You could always take the numbers in front and just flip them. Top by 7, bottom by 11. You could do that with the z's as well. Top by 3, bottom by 19. You could do that every time if you want. You do want one of these to be positive, one to be negative. So let's just take one of these. Let's say I made that negative 11. That'll handle that. So top line by 7, we'd have 77y plus 7 times 19, 133z, and then 7 times 13, 91. Great. The second one, if I multiply by negative 11, would give us negative 77y, negative 33z, and I don't know what 11 times 19 is. 209. All right. That makes sense. So now look, 77y minus 77y, gone. 133 minus 33 gives us 100 z's, and then 91 plus 209 is 300. 100z equals 300, divide by 100, and z equals 3. It gets much easier from this point on. We'll take it back one step. I have the space here, so I'm going to go here. But you can use either of these equations where it's 2 variables. Actually, you have 4 options. I don't know why you would choose option 3 and 4, but you could. I'm going right over here for the space. We have 7y plus 3z, 3 times 3, equals negative 19. So that would give us 7y plus 9 equals negative 19. You gotta subtract 9. 7y equals negative 28, and then we'll divide that by 7. Y equals negative 4. So we have y, we have z, we just need x. So we gotta go back to one of the originals. They all look about the same to me. I'm going to go with the third equation. Negative 6x plus 4y. What was y? Negative 4 minus 2z is 3 equals 8. So this is the equation I'm working on. All right. Negative 6x. 4 times negative 4 is negative 16. Negative 2 times 3 is negative 6. If we combine our negative 16 and negative 6, we get negative 22. Negative 6x minus 22 is 8. Hey, we should probably add 22 to both sides here. Negative 6x equals 30. And then divide by negative 6. 30 divided by negative 6 is negative 5. We'll write it as a coordinate, and then we'll move on our way. X Y, Z, and we're having fun. We did it, guys. We did it.